Hi, I'm Sam. I'm a first-year mathematician, and this video is designed to help people with simultaneous equations, mainly considering the algebraic case, whereas future videos will deal with applying these equations and these methods to more applied situations where the questions are given in words instead of like this simple solve and then the algebraic expression. The simplest case is equations in this form where we are already told what one of the answers is. So in this case it wants us to find the values of the variables x and y, but we already know that the variable x takes value of 2. Therefore all we need to do is find the value of the variable y. This is relatively straightforward as we just need to substitute this in to the other equation and we get the equation 2 plus y equals 4. We can subtract 2 from both sides to give the equation y equals 2, meaning that a solution to this system of simultaneous equations is x equals 2 and y equals 2, which can clearly be seen because 2 plus 2 equals 4. This is a slightly harder example but still uses the same techniques. We are given that 2x is equal to 8, that x plus 3y is equal to 7. This does not look the same, but we can easily divide the first expression and divide both sides by 2 to get the equation x equals 4. We then use the same technique as the first one, substituting values in. We get 3y equals 3, so y equals 1. So the solution is x equals 4, y equals 3. The next hardest type of simultaneous equation are equations like this one, x plus y is equal to 4 and 2x plus y is equal to 7. These are harder because we are not given an explicit value for x or for y. We have to solve both at the same time. Now there are two main methods for doing this. One is elimination and one is substitution. I will talk through each method in turn. The elimination method is all about eliminating one of the variables, which is a mathematical term for the x and y, from this system of equations to get back to equations like what we had before. So in this case, we can label the expressions equation 1 and equation 2. Equation 1 is x plus y is equal to 4. Equation 2 is 2x plus y is equal to 7. Then we can define equation 3 to be equation 2 minus equation 1. So to do this, we, for each one in turn, subtract the relevant expression from the next one. So for this one, we have 2x minus x, which gives us the x. Y minus y gives us the 0. And then 7 minus 4 gives us a 3, meaning that the solution for x is x equals to 3. We then have the equations x equals 3 and x plus y equals 4, meaning it is of the form of question 1, meaning that we can solve this by just subtracting 3 from both sides after substituting x in to this equation here, and we get y equals 1. And then what we should always do at the end is check, which is why we write the check keyword here, and then substitute these values into one of the equations. Typically you choose the equation that you have not used to find the value. So in this step here we have used equation 1 to solve for y given x. So if we check it, we are effectively confirming our own work, whereas what we want to do is put it into the second equation to make sure that it works for both cases. If we substitute it in, we get 2 lots of 3 plus 1, which is indeed equal to 7, confirming that the solution is x equals 3, y equals 1. The next method is substitution, which is where we rewrite one of the equations to get a relationship between y as x. So in this case, we rewrite equation 1, given here, by subtracting x from both sides, because x is just a number, and we get y is equal to 4 minus x. We then substitute it in, which is why it's called the substitution method, into equation 2 to get that 2x plus 4y minus, so 2x plus 4y minus x equals to 7. We can rearrange that by combining the coefficients of x and then subtracting 4 from both sides to get x equals to 3. We then substitute this back into our relationship here, y equals 4 minus x, to get y equals 1. In this case, we do not need to check it because we have already confirmed, as we've got the same answer in both these cases. But in practice, you should always check each step. When it comes to choosing a substitution, you should always substitute it into a different equation. So as if we substituted this into equation 1, we would just get 4 equals 4, which is no help, which isn't any helpful, because 4 equals 4 is always true. So we always substitute it into a different one, and then you end up with a system like the one we had at the start. Because equations where we are already given one of the solutions are the easiest to solve, meaning that we always want to get them into that form. Now, in that case, in the question 2, the previous one, we used both elimination and substitution, because it was a relatively straightforward example and both were fairly trivial to do. And to practice, you should come up with more examples, just pick some, manipulate the expression I've given, so pick x plus y is 3, or something different, and see if you can do it, elimination, substitution. Try it with both and make sure you get the same answers. In certain cases, either one of the methods may be better. In this case, elimination is more optimal, whereas you can do substitution, and it's a good exercise to try doing substitution. So with the elimination, we always start off by labelling the equations as 1 or 2, and you should do that for any type of question, because then it means we can just, like I've done here, just indicate by calling it equation 1 instead of having to rewrite it all. So if we see here, we have a 3y and a 6y, and I'm going to choose to eliminate y. So what I need to do is find a way to make sure that in both of these equations, or multiples of these equations, because multiplying any of these equations by a number does not change what the solution is. So in this case, we multiply the top one by 2 to get 4x plus 6y equals 8. And then if we subtract the second one, indicated by this minus sign here, we are subtracting the same equation, 7x plus 6y is equal to 14. And to multiply equation 1 by 2, what we've done is every time we see a number, no matter if it's on its own like this number 4, or as a coefficient, which is the number in front of this x and y, we always multiply it by 2. So the 2 goes to a 4, the 3 goes to a 6, a 4 goes to an 8. We subtract and we get minus 3x equals minus 6, which means minus 3x is equal, once again equals minus 6. Just in this case, we write plus 0 to indicate that the y has disappeared. We could equally have written plus 0y, as 0 times any number is always equal to 0. We then divide through both sides of this expression by minus 3 to get x equals 2, so we've already found half of the solutions. Now we substitute x equals 2 into equation 1 to get that 2 times 2 plus 3y is equal to 4, which means 4 plus 3y equals 4, which gives us 3y equals 0, meaning y equals 0. We could have equally substituted it into equation 2, and we would have got 14 plus 6y equals 14, which means y equals 0. Therefore, our claim is x equals 2, y equals 0, but then we still have to check by substituting it into equation 2, or if you have substituted your value of x equals 2 into equation 2, you have to check using equation 1. This means that anyone marking it knows that you've used both equations, and it just confirms that your solution works. And in this case, we get, as we've expected, 14 equals 14, meaning that x equals 2, y equals 0 is a solution. And it's a good practice to try and do this question by substitution, and you should get the same expression. I would recommend rewriting the first one in terms of x, so you get x equals 4 minus 3y all divided by 2, and then substituting it in, or rewriting y. Either one should give you the same answer, as this is the solution. Now this one is the hardest one we're going to do in this video. Is easier by substitution, because otherwise you could multiply the top by 2, but you will get the same answer, and it's a good way of showing you how substitution can be used. Obviously try it with elimination and you should get the same answer, and it's a good practice to do those sort of things. So we can rewrite equation 1 as x equals 17 minus 6y. If we then substitute it into equation 2, which I've done on this line here, keeping the brackets in case we have a minus, so we keep track of the minus signs. We then get simplifies down to this, where using the coefficients of y, so we have 19y minus 12y, which gives us 7y. And then if we subtract 34 from both sides, we get minus 32. We then divide both sides by 7 to get y is equal to minus 32 over 7. We then substitute it back into this expression here, because this is the relationship between x and y, which simplifies down to x equals 311 over 7. Typically you'll be able to use a calculator to do this, but it's a good practice on being able to do it in your head. We then get the values x equals 311, y equals minus 32 over 7. If we then substitute it into equation 2, using these values, we get this expression here, which we want to check makes sense. This does not look particularly easy to calculate, as we're going to have lots of 7s on the bottom. So what I've decided to do is multiply everything through by 7, because if this is true, then multiplying through by 7 should also give this is true, which simplifies down after multiplying out the brackets, we get 14, meaning that this is indeed the correct solution. Being able to solve simultaneous equations like this is a good technique, and you should be able to solve them in a variety of different ways. This one obviously takes a lot longer to do, and there's more steps involved compared to some of the first ones where it's very obvious to see how they're solved. Now in the next video I'll explain how you can take a real life example, form it into these simultaneous equations and then solve. But obviously if you have any specific questions you want to go through, send me an email in the link and I'll try and help.